Question 5 of the review is somebody pulling a sled. We're supposed to find the acceleration. I'm going to start off by just saying that I'm going to declare what my directions are. I'm going to say, well, like horizontally, I'm going to make to the right positive because I think that's the way it's moving. And vertically, I'm going to say that up is positive, down is negative. So it's sort of a standard, I don't have to use dash on, but that'll be my standard kind of reference. Now let's take a look here. So to find the acceleration, clearly we're going to be using A is equal to F net over M. So we need to figure out some forces. So let's just do a standard start, shall we, with some force diagram. I've got a tension force that's coming off at an angle like this. So I'm going to say this is my tension force. And then I'm going to have a force of gravity downwards. I'm going to have a friction force. So if it's moving to the right, my friction force will be opposing that. That'll be this one over here. This is the one that I know is 15 newtons. I guess if it's 100 kilograms, I could say that this is 1,000 newtons right away. I'm not even sure if I'll need that. And, well, there's going to be a normal force as well. So it'll be a normal force upwards. Let me see if I can draw that better here. There'll be a normal force upwards a bit like this. Clearly, I need to draw some components here. So when I draw this component, this would be in this direction, this would be in that direction. I'll call this one ftx, and this one I'll call fty. And I would say that, okay, that this and this together would be equal to that one. And so it's not going to be accelerating vertically, but it will be accelerating to the right. So if I make my fnet statement, I can say that fnet is going to be equal to well, ftx in the positive direction, and ff is in the minus direction, so I'll put it like that. So I need to figure out what the x component of the tension force is. You know, I've got a real shortcut way to do this. This is 120 newtons. So just by the way, just a quick little for those of you that like shortcuts, we've got a 120 newton here force, and I want to figure out what the x component is. I'll just label it fx and fy. So as long as the angle, kind of like pre-calculus classes, as long as the angle is drawn off of that positive x-axis, so this only works, shortcut, I can't spell, shortcut only works if theta drawn from positive x-axis. So for example, if we had another one and the angle was there, if the direction was there, this would be my angle. So it would be something greater than 90 degrees, for example, right? If it was here, you know, we could say, oh, that was my angle. So, but this is a really nice little shortcut. So I could say fx is going to be equal to this 120, so whatever that force was, multiplied by the cos of the angle. And the y is 120 times the sine of the angle. So you start to learn to associate my x component with cos, and you learn to associate the y component with sine in pre-calculus. But in any case, so, you know, if you don't want to use a shortcut, that's all good with me. So over here, I'm going to say this fnet is going to be equal to, well, 120 multiplied by the cos of 25 degrees in this case, minus the friction force, which was 15 newtons. So my fnet, when I type it into my calculator, is 93.76 newtons. Okay, a little calculator tip, just leave it in the calculator because you're probably going to be using that right away. Because what is my final answer? Well, my acceleration is equal to fnet over m. So again, I've still got that on my display, and divided by the mass, which is 100. So I can just move the decimal over a couple places. So I end up getting 0.9376 meters per second squared. I'd like to go back and check this out. And you know, most of these numbers here just have 2 digits that are known. So I'm just going to keep the 2 digits. So, you know, looking at those two, I'll keep the 9. The 3 is going to turn into a 4 because that 7 is larger than 5. So I'm going to say 0.94 meters per second squared. Again, I'm totally happy with both of these answers, but really when you start asking how many decimals should I keep, generally my rule is for significant figures is how many digits is all the data that was given. Keep every digit in your calculator until the very end, then round off to that number of digits. So I'm not too picky, but just for those of you that want to know. Question, oh, I'll stop now and do a separate video for 6.